Hello, today we are going to take a look at the last lesson of chapter 10, which is all about equations of circles. There are basically two parts of the lesson. One is using the equation of a circle to identify its parts and graph, and then the other is using different information to create the equation for a specific circle. The equation of a circle looks like this. It's x minus h squared plus y minus k squared equals r squared. H and K represent the x and y coordinates of the center. R, of course, represents the radius. If you take a look at this equation, imagine if you were to square root both sides of this equation. If you square rooted both sides, this is actually just the distance formula. So think about the distance formula. If you squared both sides of the distance formula, you would get this equation for a circle. And that's because, remember, a circle is just a set of points equidistant, the same length, from the center of the circle. So it essentially says here are all of the points that are the same distance away from the middle. When you have the equation of a circle, in order to find the radius, you're going to have to square root the right side of the equation to get plain old r instead of r squared. And when you're asked to identify the center comes from inside of the parentheses, h and k. But notice that the formula says x minus h, y minus k. So whenever we pull out the coordinates of the center, we're always going to change the sign of each of the numbers. So let's do just that in the first two examples. So in question number 1, we have the equation of a circle, x plus 5 squared plus y minus 2 squared equals 9. First, we're going to identify the center of the circle. So when I do that inside of the parentheses here, the formula is x minus a number. Well, x plus 5 is the same thing as x minus negative 5. So our x coordinate of the center is negative 5. Then y minus a number. This one's already y minus 2. So our y coordinate is 2. The radius of the circle comes from the right side. Remember, this is the radius squared. So if the radius squared is 9, when you square root that, the radius will be 3. To graph a circle, you always start by plotting the center first. So if I graph the center point at negative 5, positive 2, we know all radii of a circle are the same. So from that center point, I can count out in any direction 3 units. So from the center, I'm going to count 3 units to the right, make a point, 3 units up, make a point, 3 units to the left, and 3 units down. Then do the best that you can to draw something that it looks like a circle. As you'll see, I'm not perfect at this either. Just do the best that you can. The same thing works for question number 2. Identify the center and radius, and then make the graph. So in question number 2, our center comes from inside of the parentheses. We have x minus 3, so the x-coordinate of the center is 3. Y does not have anything subtracted, so that means that the y-coordinate is 0. And the right side of our equation of a circle is the radius squared. So when we square root 16, the radius is 4. Again, plot the point for your center first. Then from that center point, count out the radius in each direction. And connect the points best you can. Make something that looks like a circle. Okay, the bulk of today's lesson is really on writing the equation of a circle given certain information. So when you take a look at the next set of questions, it just says write the equation for each circle. Question number 3 has a circle with its center at the origin and a radius of 3. So if the center is at the origin, 0, 0, when we plug into the equation of a circle, x minus h, which is the x-coordinate of the center, squared, plus y minus k, so that's also 0, squared, equals the radius squared, so 3 squared. We don't need to leave those minus zeros, so let's clean up the left side to say x squared plus y squared. And on the right side of the equation, 3 squared is 9. So here's the equation of a circle centered at the origin with a radius of 3. In question number 4, the circle has a center at -2, +4, and a diameter of 4. So when we fill in our equation for the circle, it's x minus the x-coordinate of the center, so minus -2 squared, plus y minus k, the y-coordinate of the center, here that's 4 squared, equals the radius squared. So if your diameter is 4, radius is half of that, so our radius is 2, and that gets squared. When I clean up this equation, on the left I should have x plus 2 squared plus y minus 4 squared. And on the right side of the equation, 2 squared is 4. Okay, question number 5. Find the equation of a circle if it centers at -3, 6, and the radius has another endpoint at 0, 6. So in this question, just a rough graph centered at -3, +6. Here's the center of the circle, and one radius has an endpoint at 0, 6. So the circle is going to look approximately like this. When we write the equation of a circle, we need to know its center, of course, but we also need to know the length of its radius. And here they did not give us the radius directly, but we can find it. The radius is the connection of the center to any outside point on the actual circle. So I can find the length of the radius if I plug the center and this endpoint into the distance formula. So I'm going to start by doing that. When I plug these 2 points into the distance formula, let's do 0 plus 3 squared and 6 minus 6 squared. 0 and 3 is 9. Is 3. Squared is 9. 6 minus 6 is 0. Squared is 0. And the square root of 9 is 3. In this particular case, you didn't necessarily have to do the distance formula because the y-coordinates were the same. We had a horizontal radius, but that will not always happen, so you should be prepared to do the distance formula. Okay, now that we have the center and our radius, we can write the equation for the circle. So x minus the x-coordinate of the center, which is at -3. So minus -3 becomes that plus 3 squared. Then y minus the y-coordinate, which is 6, squared, equals our radius squared. So if our radius is 3, 3 squared is 9. Okay, when you flip over to the back of the notes, question number 6, we're still writing the equation of the circle. This time we're given a circle with a diameter that has endpoints at 2, 7 and -6, 15. So I'm going to do a very rough sketch of what this would look like, but let's say 2, 7 is about here and -6, 15 is up here. It says these 2 points are the endpoints of one diameter of the circle. So perhaps the circle looks something like this. If I have the endpoints of the diameter, I need to use them to find both the center and the radius. So the center, of course, is smack dab in the middle of those two endpoints. To find the center of the circle, we're going to calculate the midpoint of these two ends. So midpoint is an average. If I average the x coordinates, 2 and -6, then average the y coordinates, 7 and 15. 2 minus 6 is -4, divided by 2 is -2. 7 and 15 is 22, divided by 2 makes this 11. So we've just found the center of the circle. So I now know that this point is at -2, +11. I can then use my center and either endpoint, it does not matter which, to calculate the length of the radius. Just like we did in the previous question, we're going to use the distance formula to find the radius. So if I plug in our center, -2, 11, and I'm going to use the endpoint 2, 7. If I plug those 2 points into our distance formula, let's do 2 plus 2 squared and 7 minus 11 squared. So in the first parenthesis, we have 4 squared is 16. In the second parenthesis, -4 squared is also 16. 16 and 16 is 32. So our radius, has a length of the square root of 32. And I'm going to leave my radius as a radical. I'm not even going to simplify it, and you'll see why in just a second. Now that we have both the center and the radius, we can plug them into the equation for a circle. So we have x minus -2, so x plus 2 squared, plus y minus 11 squared equals, on the right side of the equation, we do our radius squared. This is why I left this as the square root of 32. If the radius is the square root of 32, when I square that, square root of 32 squared just becomes a plain old 32. Okay, our last two questions are a good bit more difficult. We are still writing the equation of a circle in standard form, x minus h squared plus y minus k squared equals r squared. But we're given the equation of a circle this time with all of its parts, just not written in standard form. So in order to write a circle in standard form, we're going to have to use completing the square. So completing the square is the process of taking a polynomial and turning it into a perfect square trinomial, because a perfect square trinomial factors into something that will look like the equation of our circle. When you complete the square, you're going to look at what I call your middle term, and that's your term that has just the plain old x or the plain old y. You start by finding half of your middle term and squaring it. We're then going to add that value to both sides of our equation and then factor, and we'll see what happens. So question number 7, it says write the equation in standard form. Then for each circle, state the coordinates of the center and the measure of the radius. So if we start with question number 7, we're going to complete the square twice. We're going to do it once with the x's, and then we're going to do it a separate time for the y's. So whenever I complete the square, I always set up my equation first. So I'm going to set this up as x squared minus 6x plus, and then leave myself a space. Then for the y's, I'm going to do the same thing. Y squared plus 4y plus, leave myself a space, equals 3 plus blank plus blank. Okay, completing the square is figuring out what goes into all of those different blanks. So if I look just at the x's for now, I have x squared minus 6x plus something, and I need to figure out what something goes in there to create a perfect square trinomial. So to get that number, I take my middle number, so here that's the 6. I cut it in half, so half of 6 is 3. Then I square that. That becomes 9. Again, I took the middle number 6, cut it in half to get 3, squared it to get 9. If I'm going to add 9 to the left side of this equation, I also have to add 9 to the right side of the equation. That's why I have blanks on either sides of the equal sign. Okay, then I'm going to complete the square for the y's. So for the y's, I have y squared plus 4y plus something. Again, to get that something, I look at the middle term, so I look at the number attached to the plain old y, cut it in half, so 4 divided by 2 is 2, then square it. So 2 squared gets me back to 4. The 4 goes on the left side of the equation. It also has to go on the right side of the equation to keep it balanced. Okay, now I'm going to factor the trinomial with the x's. So x squared minus 6x plus 9. If you were to look for the factors of 9 that add to negative 6, factors of 9 that add to negative 6 are negative 3 and negative 3. So instead of writing out x minus 3 times x minus 3, that's the same thing as x minus 3 squared. Then factor the y's. So y squared plus 4y plus 4. Typically we would say, okay, what adds to 4, multiplies to this 4, but adds to this one? And the factors would be 2 and 2. So again, instead of writing y plus 2 times y plus 2, we just write y plus 2 squared. And then on the right side of the equation, 3 plus 9 plus 4 makes 16. Once we completed the square and factored, notice we end up with the equation of a circle in standard form. Now that I have my equation, the directions also ask to find the center and the radius. So just reading off of this equation, the center is at 3, negative 2. That comes from in the parentheses. And our radius, when I square root the right side of the equation, should be 4. Okay, let's do this again with question number 8. So in question number 8, we have to write the equation of the circle in standard form, find the center and the radius. So when you look at question number 8, notice that the x's are not all kind of grouped together. So I'm going to rewrite this so that I have my x squared term, then my 8x, and I'm going to group them to complete the square. Plus, I'm going to group my y term, so y squared minus 14y plus, I'm going to figure out what goes in there. And then this 40 needs to move over to the right side of the equation. All of our plain numbers always have to be on the right side. So if I subtract 40, I have negative 40. And then I create the 2 blanks to remind myself to add our numbers to both sides. Okay, to complete the square with the x's, I'm going to take the middle term 8, cut it in half, square it. So 8 divided by 2 is 4. 4 squared is 16. That's the number that I add to the x's. I also add to the right side of the equation to keep it balanced. For the y's, in order to complete the square, I take the middle number, 14, cut it in half. That gives me 7. Square it, gives me 49. Add that to the y's and add it to the right side of the equation. Now I can factor. So for the x's, when I think about what two numbers multiply to 16 but add to 8, those two factors would be 4 and 4. So this factors into x plus 4 squared. When I factor the y's, I think about what two numbers multiply to 49 and add to negative 14. Those two numbers would be negative 7 and negative 7. So this factors into x minus 7 squared. And on the right side of the equation, negative 40 plus 16 plus 49 is 25. Here's my equation in standard form. Identify the center, which should be at negative 4, 7. And the radius, which if I square root the right side of the equation, is 5. Please make sure that you complete the homework attached with this. On the next day of our class, we're going to have our Chapter 10 test. So please, if you have questions, let me know. You can write them in the comment section.